This is Chapter 7, Test Review, Worksheet 2. Let's look at number 1. It says, let R be the shaded region bounded by the graph y equals root x. Okay, so that's this top curve here. Y is equal to e to the negative 3x. That's this bottom curve here. And the vertical line x equals 1. So we have our x equals 1 here. Okay, so part A says, find the area of R. So if we want to find the area of R, we see that everything is already in terms of x, so we can simply do top curve minus bottom curve between our bounds, our left bound and our right bound. Now our right bound is simply going to be x equals 1. That's the vertical line here. But to find the left bound, we have to set the equations equal to each other. We have to look at our graphing calculator for the intersecting point. And so the ordered pair, if you plug in the calculator and look for the intersection, the ordered pair is 0.239, 0.489. However, we're only interested in the x value, so we can simply set up our formula for area, which is from the integral from 0.239 to 1, top graph minus bottom graph, so root x minus e to the negative 3x, that's the bottom graph. And then the rest can go in your calculator. This is area, so 0.442 square units. Okay, part B, find the volume of the solid generated when R is revolved about the horizontal line y equals 1. So if you look at y equals 1, okay, that's going to be across the top here, and the shaded region is R. So I redrew the graph here, and we have to, if we're rotating about a line, then we have to decide whether to use washer method or this method. Now you see that there is obviously a gap between the shaded region and the axis, so we know that we're going to have to go through washer method. And anytime you have a horizontal line, you're going to be drawing vertical radius from the axis to the curve. So here from the axis, we're going to draw to the further curve, and that's going to be big R. And then we're going to draw from the axis to the closer curve, and that is going to be little r. Okay, so we need to find big R and little r. This will be in terms of x. So top of the radius is hitting the y equals 1. The bottom of the radius is hitting the e to the negative 3x. So 1 minus e to the negative 3x represents big radius. Okay, little radius is 1 minus root x. Okay, top of the radius minus bottom of the radius. And now we can plug into our washer method formula, which is big R pi, big R squared minus little r squared. And we just methodically plug this in, big R quantity squared minus little r quantity squared between 0.239 and 1. And we need a pi here as well. Okay, and then this can go in your calculator, and you'll get 0.453 pi cubic units. Okay, part C, the region R is the base of a solid. So, so now we're looking at cross-section problems. For this solid, each cross-section perpendicular to the x-axis. So the x-axis is horizontal, right? Perpendicular, we have to be vertical then. So we're going to draw a base that will be vertical. Is a rectangle whose height is 5 times the length of its base in region R. So we're drawing a rectangle, but first let's find the base. So the base is simply the distance from one end to the other end of our base. Okay, so then we're drawing vertical bases, vertical length. So we do top minus bottom. The top is on the root x, the bottom is on the e to the negative 3x. So then our base length is represented by root x minus e to the negative 3x. So if we draw a rectangle, then our base is represented by the root x minus e to the negative 3x. They tell us that the height is 5 times that of the base. So if this is the base, then the height would just be 5 times root x minus e to the negative 3x. Okay. So the area of a rectangle is base times height. And then once we have that area, we're going to plug it into our our generic volume formula for cross section, which is the definite integral of the area of a cross section dx. So then the area of a cross section is simply going to be base times height from 0.39 to 1, and our bounds are still going to remain the same as part A and part B. And then these two can combine to be squared. We can pull the 5 out, and the rest can go in your calculator. So we get 1.554 cubic units. Okay, let's look at number 2. Consider the area enclosed by x equals root y, x equals 2, and y equals 0. Let x equals k be the line that divides the area into 2 equal parts. So the first part that is not on this sheet is first find the area of the enclosed region. So the area of the enclosed region, we can do top minus bottom, so that's just going to be x squared minus 0 from our left bound 0 to our right bound 2. And if we can just go through power rule here, okay, go through power rule, and we'll get x cubed over 3. Plug in our upper and our lower bound. Okay, and then we'll get 2 cubed over 3, which is 8/3. Part B, now I can find k value because we know that this entire region has an area of 8/3. But if we want to draw a vertical line k that splits this area into 2 equal regions, then we know that each half must be 4/3. Right? 4/3 plus 4/3 equal our total area of 8/3. So we can simply just set up an equation for the left side of this vertical line. So we can say the definite integral from 0 to k of top curve minus bottom curve, x squared dx, is equal to 4/3. Okay, we know half the area region is 4/3. We just need to figure out where that vertical line is going to be. Okay, and so we can simply go through power rule again. X cubed over 3, plug in our upper bound, then our lower bound, we get k cubed over 3 minus 0. And so we can set k cubed over 3 equal to the area that we know for that region, which is 4/3. And then we can cross multiply, cancel out the 3's. K cubed is equal to 4, so therefore k is equal to the cube root of 4, which is 1.587. All right, number 3. Let R be the region in the first quadrant, bounded by the graph y is equal to 4 minus x to the 2/3. That's this graph given here. The x-axis and the y-axis. Okay, find the area of region R. So this is set up for us to do top minus bottom. So 4 minus x to the 2/3 minus 0 between our bounds 0 and 8. Now the way that we can find that bound 8 is we can set our equation equal to 0, and then we can just solve for x. If we solve for x, we get x equals 4 to the 3/2, which reduces to be 8. So we know our right bound is 8. We can plug this in our calculator, and we'll get 12.799 square units. Okay, part B. Find the volume of the solid generated when R is rotated about the x-axis. So here is our axis of revolution. We see that there is no gap between the shaded region and our axis, so we can just use this method, top curve minus bottom curve, and the formula for this method is pi big R squared, and we know big R is simply 4 minus x to the 2/3. So we plug in our formula into the calculator, and then we get 29.257 pi cubic units. Okay, part C. Right, so part C, we have it says the vertical line x equals k divides the region into two regions so that when these regions are rotated about the x-axis, they generate solids with equal volume. So no longer are we looking for equal area, we're looking for equal volume. And so we know that the total volume is 29.257 pi. So if we split that in half, we'll get 14.629 pi. And then we can simply set up a definite integral for this method for this region, just like how we did with area before. So pi big R squared is equal to 14.629 pi between 0 and k. The pi's can cancel out. We can expand this, and once we do that, we can go through power rule. And then once we go through power rule, we can plug in our upper bound and our lower bound. So we're left with this. We're left with 16k minus 3/5 times 8, k to the 5/3 plus 3/7, k to the 7/3 is equal to 14.629. Now, algebraically, this will be really difficult to solve. However, we have our calculator. So we can simply look to see where these two lines or where these two graphs are going to intersect. Okay. Even better would be if we set the equation equal to 0, and therefore we can simply look for the x-intercept. That will make things easier rather than having to look for potentially a intersection that could be off our graph for our window in our calculator. So I'm going to bring everything over equal, set everything on one side equal to 0, and then we can just plug this all in our calculator, graph, and look for the x-intercept, and you're going to get x-intercept of k is equal to 1.361.